Hello, Assalamualaikum. In this video, I will show you step-by-step solutions example for momentum analysis. Look at this example. This is example that combine momentum and pressure force. We put momentum and pressure so that we can involve whenever we say momentum, we do have m dot v. When we say pressure, we want to involve P. Okay, so definitely if you want to analyze this, you have to start with carrying out force balance F X. So force balance always like this: force, total force equal to m dot v. Okay, and then you start with direction. So you start, for example, you start with X direction first. Okay, then you can have reaction force Frx 1 plus Fpx 1 plus Fpx2. Px1, Px2 refer to what? Refer to x1. You do have Px1, Px2. Okay, this one Py2, Py1, and then equal to m dot Vx2 minus Vx1.
And then you expand these equations to become, as I show you in the previous expression, plus P1A1, this one remember, cos, involvement of cos theta 1, right? Because P1 you draw like this. Before that, look carefully with the pressure direction. It's always opposite direction, not according to the flow. So you draw the vector here, not draw the vector, you draw the direction, P1, this one also P1, this one P1 hypotenuse, this one P1, and then go up P1. So if you want to have this direction according to X direction, so
now we want to have at point 2, same.
You draw this, become the triangle, right? And then this one we go down as well. So we want to have this one, P2. So theta, so it becomes cos, right? This is P, this one P2, this one also P2. So P2 cos, P2 cos theta, okay, equal to m dot, both of them m dot. So you get outside the m dot, Vx at 2, Vx at 2, look. So again you draw the triangle, always draw the triangle, otherwise you don't know the direction. So Vx2, definitely this one is vector and this one is positive, cos theta. So how about Vx1? Is it cos or sine? Cos, correct. Minus, is positive, this one is positive, V1 minus Vx1 cos theta.
Okay, and then you got the first expression for X. How about Y expression? Now Y expression. So again you use the force balance properly, and then you get Fry
plus, look at point number 1, P1, is it positive? Yes, positive, right? This one, look carefully, X and Y, P1 A1 sine theta 1, what happened to me? Theta 1, and then look now at the point number 2, it's downward, it's opposite direction, so that means it's minus P2 A2 sine theta equal to m dot V2, again look at the X, look at the X direction, look at the point 2 direction, V2 sine theta 2, okay, minus, is it minus? Look carefully for the V, yes, because it's positive, right? So minus V1 sine theta 1, okay.
Then you can have all the expression involved. You need to figure out from this expression, figure out V2, V1, P2, P1, and then similar to area, and then theta. Usually theta is given M dot also you can figure out from the density, and then usually it's given as well. And then having this definitely require mass balance, right, to get the area and also to get the velocity. And then Bernoulli equation, we can give you the P, and then you can have finally reaction force that usually asked in the momentum analysis. Look at this elbow. This elbow, we read the question properly. The pipe bend, this is pipe bend, shown below is in a horizontal plane. Meaning what? Horizontal plane meaning it's only laid down, let's say, on the ground. It doesn't go up vertical to the air. Okay, meaning there is no y direction or z direction, it's only x direction, right? A fluid of density, sorry for my baby. So a fluid of density 878.5 kilogram per meter cubed enters the band with a velocity of 3.5. So meaning rho is 878.5 kilogram per meter cube, enters with velocity of, let's say, 0.1, v1 3.5 meter per second. Pressure at 0.1 also 280 kilopascal, given to us, both of them. Definitely you can calculate the area as well. Neglecting any energy losses in the band, calculate the force required to hold the band in a place. So give assumption the flow is incompressible, go to me. Incompressible, steady flow, and third one is frictionless. And having this assumption, then it's valid to us to use continuity equation, Bernoulli equation, and also the momentum analysis here. So firstly, I love to have a general expression that involve in the system. So as the question asks us calculate the force required to hold the band in place, that means force required to hold the band in place, meaning the reaction force. Remember reaction force? Frx, Fry, or Frz. In this case, they give us Frx, Fry, so know this one, Frx and Fry. Okay. Alright, so let's do this together. You write down the force balance, m dot velocity. Force balance could be the analysis as well. We write down the momentum expression. We start with the x direction,
And then we have Frx, Rx plus Fpx1, okay, plus Fpx2 equal m dot Vx2 minus Vx1, meaning velocity at 0.1, velocity at 0.2. So I write 0.1, 0.2. Okay, and then reaction force at 0.1, and then reaction because of the pressure at 0.1, reaction because of the pressure at 0.2. Okay.
and then you expand the expression. So Frx plus P1, we do have P1 here, A1, okay, plus, okay. Now it's a bit tricky, be careful. Usually student can mistakenly insert the numbers because of the pressure. Remember, you want to write down the pressure. So when you want to write down the pressure, you have to know the direction. Okay, as I mentioned, velocity always according to the flow, but the pressure is at the opposite direction. While you do have opposite direction P, you have to do the trigo. Okay, so they give us 35 degree, 65, this is theta. So this is P2. And then you can definitely get the pressure at this direction, right? This direction. So to get this direction, P2 cos theta. Okay, I don't want to repeat again. How can we get the P2 cos theta? It's definitely cos theta is equal to bersebelahan over hypotenuse, kan? Bersebelahan dan dibahagikan kepada hypotenuse. So basically P2 is equal basically cos theta is equal to P2 is equal to bersebelahan over P2, and then you want to have this part, so you just move the P2 to the other side and you get P2 cos theta. So P2 cos theta times area at point 2, okay, equal to, so m dot Vx at point 2. Is Vx at point 2 positive or negative? Let's see. Okay, velocity to this way, you do the trigo and the direction. Right, am I right? The direction of the velocity. So this is the velocity 2, this is the theta. You want to have this direction, right? Because this is on the x-axis. So you want to have this, you don't want this. So cos theta is equal to this part, let's say bersebelahan over V2. V2 is the hypotenuse, right? So you want to have this one, so B equal to V2 cos theta. So is it positive or negative? Look at the direction, it's negative. It's opposite. Our positive is to this direction, so it's negative. So minus, carefully put minus, Vx2 cos theta minus, why it's minus? Definitely because this one is positive, Vx1. Okay, you already know few things here. You know the theta, you know the velocity at point 1, right? Okay, but you don't know velocity at point 2. You know the area at point 1, you know the area at point 2, you know the theta as well. But you don't know pressure at point 1 also we know. Pressure at point 2 we don't know. Okay, so imagine we have to put another assumption that both point is having gauge pressure. It's not open to the air. If it's open to the air or atmospheric, that means the pressure is equal to atmospheric pressure. But these 2 points, it's still in the pipe, so that means it's gauge pressure. So if you don't have P1, if you don't have P2, definitely you can calculate it, right? Okay, how can you calculate it? Simply try to get another expression. How about expression at the y?
Y positive, so FRY plus, do we have in this direction for point 1? No, we don't have any point, because no, there's no such pressure that towards upward, so just simply put 0. Okay, plus, how about this one at point 2? Point 2, yes, they do, because point 2, since it has theta, so we can have resultant pressure here as downwards, right? When it becomes downwards, it's negative. So negative P2, and this one, I make it large. So our P2 is here. P2. Remember, it's opposite direction of the flow, and then resultant is like this. So basically, we still have resultant P2 for y-axis. So this one, if you want to have this, it's sine, right? Sine theta y-axis equal to divided by P2. Then the y-axis P2 is equal to P2 sine theta. So you guys get put down. You just quickly put down P2 sine theta equal to m dot V2. Same thing. We have V2. This one, right? So V2 is positive. So V2 sine theta as well. How about at this position? No, we don't have V2 at how about at point 1? We don't have V1 at the y direction. So it's become 0.
So fill in everything. You know the theta, you know the V2, we don't know. We don't know the V2, but we know that we can have combination of both equation 1, equation 2, then you can get the P2. So P2 calculated as, finally you get 75193 Pascal. Oh, not yet. I erase this to get more expression. Now we know P2. Okay. Now we want to. We still not finish our job, right? We just know P2. How about the reaction force? So reaction force, you fill in back to the question. Frx equal to m dot V2. Definitely we can get from what? From the mass balance, you're right. So m dot in equal to m dot 1. Sorry, m dot at point 1 equal to m dot at point 2. So m dot at point 1, m dot at point 2. Definitely rho a1 v1 equal to rho a2 v2. And because of our flow is incompressible, density is constant, you take out the density. And then area 1 is from the 200 millimeter, so 0.2, right? 0.2 times v1, velocity 1 is 3.5 meter per second, and then over, because you want to know v2, over a2. Over a2, do the same, 0.08. Yes, of 2 over 4 times, don't know. Okay, then you got the v2. So you just insert v2 back to the question. Okay, we now already know the v2. Then you can have Frx equal to, yeah, as in your notes, you can just insert v2 that you calculated. It says that v2 is equal to
yeah, you calculate, because they in the notes that I gave to you, they just insert everything on the diameter and the velocity one. So you can calculate. Okay, you can calculate. V2 cos 65 degree minus v1. V1 is 3.5.
minus, because you move the p in here to the other side. P1 is what? P1 280. Remember, 200 kilopascal is not in the original unit, so change it to become 280,000 pascal. Always do that, otherwise you will get a result that doesn't make sense. Okay, area at point 1 pi. Okay, and then what else? Minus again, P2 at the P2. So P2, do you know P2 now? Yes, you know the P2, 75193, and then again pi 0.08 power of 2 over 4 cos 65. Then you get the value for Frx, and then you get the value for Fry. Do the same Fry exactly like this for Fry. You get the result for Fry, and then definitely after that, after you get the Fry, the question asks us, you still didn't get the full mark yet, because they ask us force required to hold the band. So you have to get the total force, the summation of force. So F equal to Frx of 2 Fry of 2 square root. You get the results, Newton. And then you do the alpha, the ratio between the force at x direction and y direction, then Fry over Frx, inverse tangent. Then you get the value. This value sometimes is quite confusing as well. You get the value, for example, like let's say minus 12.5. Does it mean minus 12, or is actually at the specific quadrant? So specific quadrant, remember, first quadrant, second quadrant, third quadrant, fourth quadrant. If you do have minus, that means it's towards clockwise, it's not anti-clockwise, right? So basically for the angle we always counterclockwise, right? So this one 90 degree, this one 180 degree. So whenever it says minus, that means 360 minus 12. So you get this one. Okay, I hope you really get the point that trying to explain to you momentum analysis is something that reaction force that include in the analysis of total forces in the system that can hold a position. Thank you very much for this video. See you in the coming videos.